And now I'll be talking about Violin Plot. Well, this one is best suited when you have a lot of data, when you have a large data set. So I'm importing my Seaborn, also importing Matplotlib library. In this case, I'll be using Penguin dataset. So I'm loading my Penguin dataset and I print out Penguin dataset just to show you what's inside this dataset. So there's a species, island, bill length, bill depth. So this is actually a penguin species, and these are their dimensions, their body dimensions right here, the gender, body mass. It has all this data right here. Okay, let's compare numerical distribution across these categorical data right here. So in this case, my numerical distribution that I'll be focusing on would be flipper length. So if we'll come over here, you can see that this is my flipper length right here, and this is all numerical. So I'll be focusing on this, and I'm going to compare that with the species. That would be this one, this column right here. So this one is categorical in nature. So in this case, I specify my x equal to species. This is my categorical, my y equal to flipper length, and then I plot it. In this case, by the way, I call Violin Plot. So when I plot it, you can see this is how it looks like. So ideally, the range of the flipper length for ideally is in this range right here, from I would say from 180 to 200. Most of the data is between 100, 180 and 200. On the other hand, this species, Gentoo species, this one actually has its flipper length in the range of, I would say, 210, can go up to like 230. Yeah. So you can compare the distribution of these three different type of species, Adelie, Chinstrap, and Gentoo, by using this Violin Plot right here. So I just specify species and flipper length. This is how I got it. Okay, and then in this case, same data set, penguins, my x equal to species, my y equal to flipper length. In this case, I'm adding third category, sex right here, which would be your gender. So you can see that sex is male and female. So now it separates Adelie into two subcategories. Before that, it was only one Adelie right here. Now I'm separating this into two categories, male and female. You can see that this is the male and this is the female. And let's look at this one right here. So what is it telling me? That your males, actually you can see for, yeah, pretty much, okay, yeah, for it seems like for all three of them, the male, their flipper length is kind of a little bit longer, okay? Look at this thing, your male flipper length is in a high range and your female is low range, high range, low range. But it seems, yeah, for a daily two, male actually have a long range of flipper length. So you can see that from here. Okay, now I'm actually doing the same thing, but I'm saying fill equal to false. So by specifying fill equal to false, it's not going to put anything inside. This is going to be just without filling. Okay, then I'm separating male and female. So in this case, you specify split equal to true, and you can also say inner equal to quad. So by specifying these two parameters, it's going to give you something like this. So in this case, you can see that it actually split in male and female, so it's plotted right next to each other. So instead of plotting like this, it's actually plotting that all in one single plot right here. So this is my male on this side, this is my females, and you can see that these are my quartiles. So let's look at this one. This is my Q1, Q2, and Q3 for males. And this is my Q1, Q2, Q3 for females, and that would be a daily species. Same thing you can read, similar way you can read these ones too.